Okay, a little bit of an update. This is the Z-axis servo for the Trak DPM mill. I've got it all wired up. And then I have the X-axis servo right here. It's all wired up. And here's the leads. And then here is the Y-axis servo. It is the same as the X-axis servo. Same brand, same specs, same model, same everything. Though after I wired these up, I kind of make sure that everything's good inside here. Most notably the DC power supply wires to the motor. And per Centroid, in anything else, but per Centroid, you have to follow this tech bulletin to make sure your servo motors are. You have to follow this bulletin to make sure your servo motors are good. So what I noticed is while it passed the test, I did a resistance check, and let me show you on the windings. So here I've got my DMM, and this was the giveaway. The resistance on this motor is 3.4 ohms. Now I'm going to hook up the X-axis motor. And look at this. It's 4.8 ohms, 4.7 ohms. That's quite a difference. So then I proceeded to test the motor on my bench power supply. Kind of built this. It's a Variac with a bridge and a large capacitor inside for testing motors like this. So when I was testing it, it ran, it turned, but it blew the 10 amp fuse in my power supply. And I said, okay, something's definitely not right here. Hooking this up. And I'm going to turn this all the way down. Turn it on. 2 volts. Just going to take it up to about 10, 12 volts. And you'll see the motor's turning. And I'm going to put my clamp meter on here. And I got 1.2 amps at 11 volts, and that's a lot. So if I turn it up a little bit more, there's 21 volts. Got 21 volts. Now I got 2.5 amps. Well, I shouldn't have that kind of current draw. There's no load on the motor. If I take it up anymore, I'll blow that fuse. So now I will show you the X-axis servo, which is identical. Kind of hard to do this one-handed. Okay, there's that. There's that. I'm going to turn my power supply down, turn it on. 10 amps, or sorry, 10 volts. You see the motor's turning. And I'll put my power supply on it. Barely anything. I'm sorry, power supply. My clamp on amp probe on it is 0.2. I'm going to take this up. There's 22 volts. Again, barely anything. Point 0.3. Now I'm going to take this up to 50 volts. You can see the motor spinning away there. My clamp on. 0.4 amps. So this motor is definitely bad. I did run the checks, and I put my meter to the chassis of the motor, and then to one of the wires, and then I proceeded to turn the shaft while it was on the resistance scale, and it didn't move. So anyway, so the bottom line is this check is very much required before you connect these motors to the all-in-one DC. If you have a bad motor like this one, you could potentially blow the output of the all-in-one DC. So it's unfortunate. This machine has very low hours, and this was the y-axis, and while it does run, if it was asked to run very fast, it would have caused a problem and eventually probably shorted out the drive. Fortunately, I have a Glentech DC servo, which is very close to this one. My problem is this has a 6mm shaft on it, and that had a 1/2-inch shaft, so I have to get another encoder for this one. So I'll be able to swap that in once I get an encoder. And I have 2 of these, and I just save stuff like that for this very reason. Sometimes it can get me out of a pinch, and looks like it'll do that here. So anyway, bottom line, make sure you follow the Tech Bulletin 155, and I believe this is the process here too, and I believe that's on all-in-one DC. Let me look. Sure is. It's on all-in-one DC. So if you blow all-in-one DC because you didn't run this test and your servo motor's bad, and trust me, you send it back to Centroid, they'll know, and they'll repair it, and it'll cost you a few $100. So again, make sure you follow the Tech Bulletin 155.